Okay, students, so now let us start a class. Okay, I hope I'm audible to all of you. Okay, so now we're going to start a class. Just hold on. Yes. So let us start it. Am I audible, students? Yes? Yes. So that's fine. Let me check on the YouTube, okay? Okay. So let us start a class, okay? As I've seen that you all have joined, okay? So on the YouTube also the students are visible now, they're clear. Let us see. Yes. So on the YouTube also you're visible. Okay. So what are the things which you have studied in the previous classes? Let us see. First of all, let me launch the technical checkup, okay? So I have launched this technical poll. Please participate in this poll. I hope it's visible on your screens. Am I audible? Are the slides properly visible to you? Submit. So please participate in this technical checkup, okay? So I have removed this thing. Now let us start the class. So next slide. See, these are all the revision things which we have already gone through, isn't it? These are what? Revision things which we have already gone through. What is ray optics? Okay, you know this thing. So let me use the pen. Yellow is fine. We have completed this already. We have also completed this. We have completed this also. Okay. Then what was the next thing? If you see the next thing, see, then we have seen what? New point revision. Okay. Let me show you this. Okay. So then we have seen like spherical mirror. Okay. So this is also completed. Fourth topic. Then we have seen what? Some important terms related to spherical mirrors. Okay. Then what? The numericals you'll see. Okay. We'll solve the numericals also. Okay. So you might be finding it some noise, but no issues. Okay. That's fine. Spherical mirrors, some important terms and numericals. So this was all from the revision. Now let us see the next thing. Yeah, these all revision parts is all already completed, students. Okay. So you have seen what is ray optics, these all things. So notes will be provided to you. Don't worry. Okay. Notes will be provided to you. We have studied this also, this also, this also. Well, we have studied what is ray. We have studied what is beam. We have studied reflection process, phenomenon. We have studied plane mirror. We have studied this laws of reflection, formation of images, relation between object speed, image speed, and mirror speed. Okay. We have studied this spherical mirror connection between image, I mean, all these things, image, object, and focus. But before that, we have seen these things also. What is pole in a concave mirror? What is this principal axis? What is this radius of curvature, center of curvature? What is this? We have seen also what is focus. We have seen aperture. What is aperture? We have seen focal plane also, isn't it? Yes. Then we have seen some rules for image formation. Okay. Then we have gone through some rules. That is, if the ray is parallel to principal axis, what's going to happen? It will pass through the focus. And then we have seen that if a ray passes through the focus or appear to pass through the focus, as the case of convex mirror, it will what? Retrace its path. Sorry, pass through curvature, center of curvature. So for ray, let me use different color. Okay. So yeah, some students have joined. That is from JNV Sangli. So welcome, Sangli students. Okay. So suppose a ray passes from this center of curvature in case of concave mirror. This is what? Concave mirror. So the ray will retrace its path. Okay. And if ray appears to pass from this center of curvature, okay, again it will retrace its path. But in this case, it is what? Convex mirror. Is it fine? And this is what? Concave mirror. This is concave and this is convex. Is it fine, students? Now let us see the next thing. If students, if any one of you is feeling any doubt, please text in the chat box. Yeah, 2 of the JNV Sangli students have joined. That's good. If any one of you is feeling any doubt, please text in the chat box. Okay. Is it fine? I hope it's clear to you. Is it fine, students? Yes. So now let us move towards the next. Yeah. So this is the point. It is easy to make ray tracing of a ray incident at a pole. So this was the 4th rule. Okay. That if a ray passes, I mean, it strikes the pole with some theta angle, you know, by the laws of reflection, I equals to R. You know this thing. Suppose I'm treating this a point of incidence of this ray, which is incident ray. If I consider this part of this mirror, it is behaving as what? It is behaving as concave mirror. Okay, it is behaving as concave mirror. So the ray which will pass will make an angle I equals to R theta theta. Okay, that's fine. Now let us see the next thing. Hold on. Now we'll see the next thing here. So what is the next thing? If you focus here carefully, we were at this point, okay, in the class. And then what? Just wait a second. Yes, now it's okay. So after this, if you see, this was the rules of image formation. Then we have seen a relation between object distance, image distance, and focus. What was that? This was the relation. Yeah, we've already studied this thing, isn't it? That 1 upon V plus 1 upon U equals to 1 upon F. F is what? F is focus here. F is what, students? F is focus here. Is it clear? Yes. So you can also participate in the chat box. Okay. It's really important. Next thing, what we have studied. What was the next thing which we have studied in the class? Anyone of you? Next thing which we have studied in the class. Anyone? What was the next thing which we have studied in the class, students? Okay, let me tell you. So then we studied this thing, that is, yeah, difference between the virtual image and the real image. What is the difference between the virtual and the real image? Okay, so from this picture, it's already clear to you. I mean, it's very much clear to you. That is, if an object is kept in front of the plane mirror, let me show you this red pen. This is object, this is plane mirror. So you know the concept. When the object is kept in front of the plane mirror, what suppose this is a plane mirror. Object is kept like this. So what happens? Object distance equals to image distance. This you have seen. So this is object distance. This is equals to image distance. Okay. And suppose now this is a part of the mirror, which is basically, you can say, concave mirror. Okay. Now suppose concave mirror is there. One of the spherical mirrors. Okay. This is what? This is one of the spherical mirror. So if you keep an object here, if you trace the ray diagram, or if you draw the ray diagrams, you will find the image here. Also by using the formula 1 by V plus 1 by U equals to 1 by F, somehow you will get the distance of the image as this. And this image is inverted, but real image. So that's the difference between the virtual and the real image, students. Virtual means in the what? Mirror world. It's very much illusion. and real means which you can take on the screen. Fine. Then we studied what? What's the next thing which we studied? Anyone? Yeah. So in the previous class, that is yesterday, in the previous class, if you see, so that is yesterday's class, I told you that we will be studying reflection, total internal reflection, and apparent depth, normal shift, and also, but before all these things, I told that we'll solve a question in which a spherical mirror is moving, object is moving, and image is also moving. So what's the connection between the formulas of these three things? And when I say mirror, I mean basically here spherical mirror, because students, you already know this thing, that mirror, I mean, if you see about the previous lectures, when we have taken this same topic, but under the category of that plane mirror, we know the formula was what? Velocity of object, velocity of image upon velocity upon 2 equals to velocity of mirror. But that was for plane mirror. Now we again have to find these three formula based on this relation, that is UV and mirror speed. But here the mirror is among the spherical mirror, that is concave or convex. Okay, that's fine. Students, you may appear my video may be going off and on again because it's like to avoid technical error. Got it? So this is what relation between VU and mirror speed. So we'll find this first. Then we'll go for refraction. We've already seen in the previous class. Refraction we have already seen in the previous class. Then total internal refraction. Today's main focus is this. Then apparent depth also. If we can complete. Got it? Yes or no? Please text in the chat box. Yes or no? 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 Anyone? Okay. So now let us move. Students, we were on this question. Got it? In the previous class. So in this question, what was happening is this. This was spherical mirror. It was moving with 1 centimeter per second. Okay. You know this? Yes or no? And the object distance U was minus 30 here. Focus, of course, it's a concave mirror. So focus is minus 10. And speed of this mirror is 1 centimeter per second in the negative direction. And speed of the object is here 2 centimeter per second in the positive direction. Okay. So it will be asking from you the image speed here. Got it? Fine. So how to find it? I hope I've given you the formula. So this is a derivation of this. I've already kept here. Students have already given here the derivation. Okay. I mean, this is basically formula. Derivation is in the next slide. This is formula and the derivation is on the next slide. So this formula says you what? This says like this. Velocity of object equals to minus v square u square velocity of image with respect to mirror. Okay, this formula you have to remember. So see, suppose if someone asks from you the question ki ek concave or convex mirror move kar raha hai and object is in front of that and find the image speed, how you'll find? You'll use this formula. So in the ground frame it is like this. It's in the ground frame. Got it? Of course, because when you will open this velocity of image with respect to mirror, it is what? Relative velocity concept pada hai na? We have studied that thing. So we say what? Velocity of object minus velocity of mirror, or velocity of image minus velocity of mirror. Okay. And that velocity of image minus velocity of mirror is basically from the ground frame. Kinematics mein, riverboat problem mein, all these things we have seen. Na? Got it. Now next thing, students. Derivation is this. You can note it down. I'm giving you time. I'm giving you a few seconds. If you want to note it down, you can. See how to derive this formula. This formula is for what? This formula is for the case when spherical mirror, say concave mirror or say convex mirror, is moving with some speed. An object is also moving. And we need to find the connection between three things: velocity of object, velocity of image, and velocity of mirror. So how to find it out? What's the way? The way is this. Because since it is for, see students, since it is for spherical mirror, connection is for spherical mirror. Okay, we'll do what? We'll take the spherical mirror formula, we'll differentiate this, we'll get this answer. Okay, and when you will apply this formula in that question, that is this question, it's very easy. Answer will come out. Okay, so for information, I'm giving you the answer here. See, I have to apply formula like this. Velocity of object is basically what? 2 centimeter per second. Velocity of mirror with respect to, so it is what? Minus, I'm applying directly the formula, okay? Check your answer. I mean, I'm giving you this question. I think we have solved already. So this is -1 here and minus v square. V you will get as 15, minus 15 square by the formula of the mirror connection formula. That is 1 by v, 1 by u equals to 1 by m. And this is 30 square. That is object. And again, it is image, velocity of image minus mirror. That is minus of -1. So when we will solve it, this is 1 by 4. Okay, that is 3. And this is -1 by 4. And that is again plus 1 by 4. So let us solve on the next slide. Okay. Hold on. Okay. So students, I'm giving you direct answer. We don't have time, a lot of time. 7 by 4 centimeter per second answer will come out. Velocity of image. Got it? So you can do this question as a homework. इसको homework कर लेना. Do this as a, solve this question as what? As a homework. Got it? Formula you have to apply this only in this case. Use the sign and conventions as what? That if you're going against, if you're measuring the distance, if you're going against the rays of the object, it's negative. It is same. So take the speed, velocity direction and going against the ray direction negative to be same. Okay. So it will be negative here. That is velocity in this direction is negative. And going from the pole, measuring the object distance or image distance, if it's against the rays, it is negative. Okay. Now this topic was left. I told we'll solve in the next class. I've given you this question as a homework, by the way. Okay, maybe you are not able to solve. I'll solve this question for you. Okay. I'm going to solve this question for you. Is it fine? I'll be solving this question for you, students. Okay. So let me explain you how to solve this question. It's very easy question, by the way. One among the very easiest questions. Okay. So just you must know the approach. If you know the approach, you can solve this question. Got it? Is it fine? Okay, so let us start it. See, this question is from the combination of mirrors. Since nobody is texting me, I hope that it's clear to you. Okay. I'm using this pen. Okay. So this question is from combination of mirror. I'll tell you how to solve first, second two questions. If anywhere you find this kind of question, you know, Avanti models and or anywhere, you can solve it at least. Okay. This is what, students? This is concave mirror. Okay. This is what, students? This is plane mirror. Now the question is this: taking first reflection of the object from this concave mirror, find the final image form. Okay. So process क्या होगा? Process ये होगा. First reflection will be from the concave mirror. Then you will get first image. That image will be acting as an object for the plane mirror. Then you will get a second image, and then second image will be acting as a object, a virtual, sorry, a virtual kind of object for concave mirror. Okay, and a virtual kind of object for this concave mirror again, and there will be third reflection. So the question is this for you students: key allowing three reflections. By allowing three reflections, find the final image. Find the final image. by allowing three reflections, find final image. Okay, so it's very easy. First reflection, so it will be given in the question. No need to get confused. See, if you think by common sense, you will find कि ऐसे तो बहुत reflections होंगे. Yes, it is, but they will specifically, individually, peculiarly give you in the question that you only have to take some reflections, say 2, 1, 3, and get the final image. Also, they will give you how to start the question. I mean, how to start the solution, from which mirror you need to take the first reflection. That you will also see in the next question more better way, in a more better way. Okay. So yes, I hope it's clear. So now let us see. This is what concave mirror. Concave mirror. Object is 15 centimeter here. Okay. Object distance. See, if you start from the pole, go towards the object. What is it? Start from the pole, go towards the object. It is object distance. Okay, so it will be what? -15. Is it fine, students? I hope it's clear. I hope it's clear, students. Okay, so when you start from the pole, go towards the object, it is minus 15, you know, we can see we are going against the object rays. And the radius of curvature is also, because it's a concave mirror starting from the pole. If you go towards the radius of curvature, it is again negative here. So this is say minus 20. But we need focus, which is defined as r by 2 as magnitude. So it will be minus 10. Now when you find the image distance, students, by this formula, we'll get as what image distance? It will be equals to 1 by v, okay, minus 1 by 15 minus 1 by 10. When you will solve it, you can see what is coming. 1 by 15 minus 1 by 10. See, you can also answer in the chat box in the Zoom or on the YouTube, no issues. So when you will solve it, this will be what? 1530 is what? What is this, students? It is 30 here. Minus 1 by 30. So you will get image as minus 30. Got it? You will get image as minus 30 here. Is it fine? You get image here as what? Minus 30. Got it, students? So where were we? We are in this v equals to minus 30. Okay. So now let us move towards, if we go to v here. So let me draw this image again. This is what concave mirror. So we are having the radius of curvature as, what's the radius of curvature? Minus 20. Focus will be minus 10. If I move, switch back, u is what? Minus 15. Minus 15 will be here. Okay. So focus is what? Minus 10. Fine. Image we get at what? When we solve the image, what the image we are getting? What is it? V equals to minus 30. That is this. Fine. Minus 30 will be where? So if you see in the image, see what is happening here is this. This plane mirror is at 40 centimeter distance from the concave mirror. Plane mirror is at 40 centimeter distance from the concave mirror. And image is where? Image is at 30 centimeters. So it is here. So the gap remaining is 10 centimeter. Okay. So if I draw on the next slide, I was having here what? Say, I was having it as what? Mirror. So image which I'm getting here as what? This. And the gap is what? 10. So here image will be 10 here. Okay. This is the image here. Okay. Now this image will be acting as a virtual object. Let me show you. This image will be acting as a virtual object for this concave mirror, which is a distance how much? 40 plus 10 centimeter. Okay. That is 50 centimeter. If you see back, see this. This is the image forming, which is at distance equals to 10 centimeter. Okay. And total distance is 40 plus 10 centimeter. 40 plus 10 means 50 centimeter. Got it? This is how much? 50 centimeter total object distance. This is basically what? This is virtual object. Let me show you here. By the way, this object is what? It has been treated as a virtual object. Okay. It has been treated as a virtual object. Now, if you solve this question, see, so the question becomes like this. That is, suppose you are having here what? A concave mirror. This is what? A concave mirror. And this is principal axis. So now for you, actually this virtual object kind of thing, is at how much distance? It is 50 centimeter. Okay. And radius of curvature will not change. Okay. Because we haven't, we haven't done anything with this concave mirror. Any modification, any alteration, we haven't done anything. Okay. So what's going to happen? If you see the concave mirror, what are the changes? Nothing. So radius of curvature again is 20 only. So focus will be -10 by the convention. Object distance is -50 by the convention. So final image which you will get is this. That is, apply this formula again. So the final image is how much? 1 by V minus 1 by 50 minus 1 by 10. So this is equals to, okay, this will be equals to what? If you solve this thing, what the answer you getting? Anyone? What answer you will get, students? You will get this as an answer. That is -4 by 50. Okay. So this is something as -12.5. So your answer which you will get is -12.5 centimeter. That is, image will be somewhat here, final image. And this is your perfect answer. I hope you got the solution. V equals to -12.5 is the right answer, students. Is it clear? So what happened? Let us at last conclude everything. Okay. So see, ये क्या है? This is concave mirror. This is what? Plane mirror. So first object का reflection went from, the first reflection which occurred for this object is from this concave mirror. Applying this formula, you get the first image. That is here, 30 pair. And the gap is 10. So again, this image will be acting, which is a real image basically, will be acting as an object for plane mirror. Again, you will get a reflection in the plane mirror using the concept object distance, image distance, perpendicular from the mirror. 10 centimeter, second image you will get. This second image will be acting as a virtual object for the concave mirror again. Okay. Then again, you will apply the formula. You will get what? You get this thing, that is a final image. And this is a real image. Okay. And this is your answer. That is, the answer of this question is, finally, we'll get the image after 3 reflections at a distance 12.5 from the pole, or you can say V equals to -12.5. Let me write it here. So finally, what students will get an image at 12.5 from pole or vertex. Got it? Finally, we'll get an image at 12.5 from pole or vertex. Okay, I hope it's clear. That's fine. So one more question based on this combination of mirror. This you have to do. Okay, I'm giving you as a homework, or you want me to do? Any one of you can text in the chat box. Let me see the YouTube students, what they are doing. Okay, what's happening there on the YouTube? Okay, that's fine. So this is a question also based on combination of mirrors only. Okay, so what do you need to do in this question? What they're asking from you? What they're asking? So if you focus here, again, you're having what? One mirror, other mirror. This mirror is what? Of course, it is, we can see it, it is concave. What is this kind of mirror? This is convex. Concave and convex mirror. Okay. And the object is kept at 45 centimeter from this concave mirror. Okay. And at 10 centimeter from this convex mirror. So they're asking from you, taking first reflection from this mirror one that is convex and adding towards the final image. I mean, before that, take at least 2 reflections, only 2 reflections, strictly, not at least, strictly 2 reflections, and then find where will be the final image formed. Okay, where will be the final image formed? Got it? Is it fine? Yes. Okay, cool. So now we'll see it, how to solve it. Okay, I've given homework, but somewhat I will try to solve now only for you students. Okay, so see it carefully. Okay, so first they are saying what? Convex mirror, convex. Okay, so object is here at 10 centimeter. Okay, focus is 10 centimeter. Fine. And first reflection we have to take from this and then find the image formed by this first reflection. Okay, so apply the same formula, 1 by v, 1 by u plus 1 by f. Got it? When you apply this, you'll get what? U, if you go from the pole towards the object, it's against the rays, minus 10. Focus, it's convex mirror. So if you go from the pole towards the center of curvature, that is focus side, this is what? Positive here. Okay, this is what? Positive here. So this is 1 by v minus of minus 1 by 10, 1 by 10. So when you find the image, this is equals to what? Minus 1 by 10 and plus 1 by 10. Okay, hold on, this is focus. Okay, focus is already given to you, it's positive. And when you will send this, what the answer you're getting? What will be your answer, students? See this. Just hold on. This is 10, u equals to minus 10, and this f equals to plus 10 for you. Just put the values. U equals to minus 10. Okay, yeah, it will be minus 10. Fine. So you'll get twice of 1 by 10. So when you will solve it, okay, let me erase this thing. That's fine. No mistake here. So when you will solve this thing, you'll get 2 by 10. That is 1 by 5. So v is equals to plus 5 centimeter. Okay. So the final image forming due to this first reflection is at plus 5. Plus 5 means where? What do you mean by plus 5 thing? What do you mean by plus 5 thing? What is it? It means going from the point, going from the polar vertex towards the, in the direction of the rays, it will be positive direction. So it is here, plus 5. Okay, image 1. Now this virtual image will be acting as a kind of virtual object for this concave mirror, and this will be second reflection. This will be our second reflection. And the last, because it's given in the question, you only have to take 2 reflections only. Okay, you only have to take 2 reflections only. Got it? Is it fine? Okay, that's fine. So now let us solve this question. It's very easy for you, for us. Okay, now the total distance of the object is how much? 45 plus 10 is what? It's 55 plus 5, how much it is? 60. So now we are having the question in this way, that is, suppose you are having a concave mirror. This is what? Concave mirror. And we are given here object is at 60 centimeter. Virtual object. Okay. And focus is how much of this? What's the focus? Focus is 20 centimeter given already for this concave mirror. F is given as 20 centimeter. So going from the object or pole or vertex towards this focus, we are going against the object. Right? So again, F is what? Minus 20, and object is what? Minus 60 centimeter. Okay. So you will get the final answer as 1 by v plus 1 by u equals to 1 by f. So you will get what answer? Answer will be what? Any one of you? Nobody is responding here in the Zoom. So at least respond on the YouTube chat box. Okay. Is it fine, students? Okay. So what you need to do is this: 1 by v minus 1 by 60 minus 1 by 20 minus, you got it? No. Why? Because we are going against the direction of the object rays. Got it? So when you will solve this thing, just solve it and you'll get the answer. Final answer of this question is what? 1 by 60 minus 1 by 20. Solve this. What is it? So this you will get as how much, students? 6, 1, 3, 10. That is minus 2 by 60. That is 30. So you will get the final image at v equals to minus 30. That is somewhat here, half. And this is the final image. So the answer is this, that if I go back, answer will be this. I will write this answer as solution of this question as what? You will say like this if you want to like theoretically say to someone or just narrate the solution, explain it, conclude it. So you can write like this, that image, more properly if you want to say, final image after 2 reflection will be at 30 centimeter from pole. 30 centimeter from pole. Okay. Is it fine? Good. Now, refraction of light. This we have already seen. Little bit of the revision it's required? No, because you know this thing. Okay. So a little bit I will revise, just very little bit. Suppose you are having a speed of light, say like this. This light is going and it is having c speed in, say, suppose air or vacuum. Okay. And I'll say that suppose now we take a bucket full of water like this. And again, if I project this light there down, so now the speed will be not this c. What will be the speed? Speed will be now nu, that is c by refractive index of this water, which we know already it is what, 1.33. Or if it is glass, it will be what? Glass में speed कितनी होगी light की? It will be c by, again, refractive index, that is 1.5. This we have already seen in the previous class, yesterday's class. Okay, I hope this thing is clear. These are very easy things, students. Okay, and then we have seen these 4 points, which are basically, I mean, yeah. So then we have seen these 4 points. It gives you some information about the refractive index and its properties. That is, higher the value of refractive index, more denser optical is the medium. Yeah, this is fine. And now why it is? Because if you focus here, this is what? Air. It is having a refractive index as 1. This is what? Water. It's having average value of refractive index as what? Now you'll ask, what is refractive index? We have already seen this, no? It's a property of the medium is defined as a factor by which the speed of light, what happens? Reduces, okay, as compared to the speed of light in vacuum. It's due to this formula only, students, I have made this conclusion here. It's due to that formula only we have made a conclusion here. Got it? I hope it's clear to you. Okay, it's fine. So we got about the refractive index. We got about this 3 points also. Yeah. So here I was explaining, if refractive index is 1.3 for water, for glass it is 1.5. You can see from just divided. So we'll say like this: vacuum, water, and glass. ठीक है? Glass का refractive index is greater than the water. Water का refractive index is greater than the vacuum. So as you can see, the order of increasing here, I mean decreasing. Glass से water से vacuum. So we'll say that water is having more denser optic. It's more dense, optically denser. Okay, then this vacuum, and this glass is more optically denser, twice plus than this water. Got it? Is it fine? Yes. So more refractive index, more refractive index means more what? More refractive index means what? More what? More optical density. More optical, we can say more optical denser is the medium. The medium which is having more refractive index, it means that medium is optically denser. Okay, optically density will also be more. Got it? Now what's the next thing? Now, yeah, this video also we have seen, isn't it? This video also we have seen already. And what is happening in this video? We have seen this video. What is happening in this? That there was a magic wand, it break from between. I mean, it was appearing that it has break, okay, but it was not. So when the person, sorry, when the person got the knowledge of refraction, he was able to explain that this magic wand was not broken from between. Got it? Yes. Next. See, this was the person, no? We have seen this video already. Do you want to see it one more time? Yes or no? No. So he's also saying no. Okay, so leave it. Yeah. Okay, little bit I'll show you here. So what happens? It was this magic, and then suddenly it breaks. I mean, now a tub will appear suddenly, and when the tub will appear suddenly, you'll move aside. He'll move aside. Okay. And now he's not feeling bad. He's really feeling bad now. Okay. But it was due to the lack of knowledge of reflection. When he studied about reflection, when he thought about why when I took out and I was appearing to my eyes like it's not broken, and when it was inside, I was feeling that it's like from between it's tilted, or my magic wand has been not in love. It's will not work for magic now. So when he got the knowledge of reflection, he became happy that yes, his magic wand is not broken. Okay, so it's due to the lack of knowledge of reflection. Got it? Fine. So after that, we have studied the laws of reflection. That this first law, that incident ray, refracted ray, and the normal to the plane of incidence will all be in the same plane. Okay. Next law was this, which is known as Snell's law, which says you sine of the incidence angle in this first medium upon sine of this refracted angle in the second medium. Divide karenge, so it is what? Constant here. It will be constant. Okay. This is what? This is Snell's law. So sine I upon sine R, N2 upon N1. You can see what is the most important formula to remember in this reflection topic. This is the most important formula. See, if you're remembering this, automatically your rest of the things are been like remembered by you. Okay, let me tell you, let me explain you this thing. This is what N1 sine I, N2 sine R. It's fine. And how to remember? First, remember how to remember this formula. What's the trick? Trick is this. Start from any of the medium. Don't worry, it's having more refractive index than the other or less. It's denser optically or optically rarer. No issues. What you need to do is this. N1, if you are standing in this medium, say N1 multiply the rays angle with the sine of that. Okay. So sine I. Equate this with next medium's refractive index and the ray which is present in the next medium. Uska angle ka sine. Whether it can be I or it can be R. You understand? If I start from there, again the formula will be same. So N2 sine R. उसी medium का refractive index and multiply the angle with sine. Next medium का refractive index, multiply the angle with sine. Take the sine of that and multiply that. Okay. So you will get this. Now students, just divide this sine I by sine R. If I remember this formula, if I'm dividing this sine I by sine R, this is mathematically what Snell told. Sine I, sine R, he actually observed experimentally, then he has given this mathematical law. Okay, so what he told? He told like this, sine I upon sine R is what? Something a constant. Okay, and we know this thing now from the formula. We can do this. If I put sine I upon sine R, and if I substitute this upon at the denominator of this, I will get what? I will get N2 upon N1. Got it? Yes. And just now you have to remember these two things. Now, how you remember? You know this thing that that speed is equals to C by refractive index. If I put C will be constant always. So if I put one subscript here, and I can put one more formula like this, C by N2. Okay. So from this, you can find V1 by V2 like this. You can prove this thing. And if you have V1 by V2, we know V is equals to lambda by time period. And if frequency, we know we have remembered the point in the reflection, also in the properties of light, that frequency always remains constant. So students, if the frequency is constant, time period will also be constant. Okay. So lambda will change. So with V1, lambda will change. T will be fixed. So from here, you can again prove if here V1 is proportional to lambda 1. That's why V1 lambda 1 upon lambda 2 will be in series with it, in proportionality with it. Okay. In proportionality with it. Okay. Got it? Yeah. This is a representation of refractive index with respect to some other medium. Okay. Okay. If it's somewhere you find this, don't worry. Okay. Don't like think what's happening here. It is basically you will read like this. If 2 is in the subscript and 1 is in front, you will read like this. What? That is refractive index of the second medium with respect to first medium. Refractive index of what? Second medium with respect to first medium. That's fine. Okay. So C is what? Speed of light here. I and R should be taken from the normal. Taken from the normal means this is incident ray. This is refracted ray. Taken from the normal means what? IR here, like this. Take the angle like this. Got it? So now we'll go towards the next thing. Yeah, this question also we have solved. Okay. This also we have solved. So just give me the answer how to solve this question. I mean, in the previous class, we have solved this question. Okay. So I'm solving this question again. Okay. So we'll see how to solve this. I mean, if you are not able to get in the previous class. So this angle is what? So it's one of the easiest question we'll find. This is what? Theta angle. Okay. So just apply the laws. N1 sine theta or I, N2 sine R. Okay. N1 is what here? 4 by 3. Sine theta. This angle already is given as sine inverse 3 by 5 for theta. So sine theta will be what? 3 by 5. Put this value here. N2 is what? 1 sine R. You need what? You need theta A, which is basically R here. Okay. When you will solve this thing, you'll get R sine inverse 4 by 5. That's fine. Yes. So this is your answer. We have already solved this. Doubt must not occur. Okay. Now, students, let us start the total internal reflection because it's pending now. Okay. Now we'll start the total internal reflection. Is it fine? You've completed. Some students may be having the doubt in the refraction part, but now it's completed. Some students may be feeling doubt in the reflection part, but now it's completed. We've also solved two problems on the combination of mirrors. Big problems they were. Okay. They were not like an average. I mean, the low level. So now what is total internal reflection? See, if you focus on these three words, total internal reflection, total internal is fine, reflection. Why, sir, you have included this thing in this reflection topic? What is your problem? I mean, there is no issue in this, but actually you will see that how the reflection occurs when the angle increases. Okay. So suppose you are having this glassy material. This is what? Some glass, or say suppose ball is ball is present. Suppose some bowl is present, okay, and the water is present in this bowl, okay. This is what? Glass. You can take anything, glass or water in the bowl, okay. Whatever, it will be having a denser optical property, okay, or it will be optically denser medium. So it will be having refractive index as glass का कितना होता है 1 point, how much? 5. Water का कितना होता है 1.33. Okay. So now see, suppose I project a ray from optically denser medium to optically rarer medium. Of course, if this is glass or water, it will be yeah. So I hope it's visible now. Okay. So what I told, suppose a ray goes from optically denser medium having higher refractive index to optically rarer medium. Okay. So whenever the ray goes from optically denser medium to optically rarer medium, it bends away from the normal to both the mediums. I mean, the boundary separating both the medium. It always bends away from the normal. Okay. And when the ray goes from optically rarer medium to optically denser medium, what happened? It always bends. When goes from optically rarer medium to optically denser medium, it bends what? It always bends towards the normal. Okay, remember these 2 points. These are star points. Okay. Now, if you focus here, see this ray is going from optically denser to optically rarer. It is bending away from the normal. Okay. Now suppose if I increase the ray angle, this is what optically denser medium. If I increase this ray angle, that is if this theta I is increasing. So what's going to happen? This angle which this refracted ray is making with the normal, it will also increase. Hai. Suppose if I increase the theta I, of course you know this thing. Ray which is going in the other medium will be having some angle R which is greater than the I here. So if I increase the R which is greater than the I here. So refracted angle will be greater than the I angle. So if I increase I, what's going to happen? R will increase. So at certain limit of this I, that is equals to C angle, which is known as critical angle. Angle of refraction will be 90 degree. Okay. So at a certain limit of I angle, that is equals to C, which is critical angle. Angle of refraction will be 90 degree. Okay. So such a angle, such a limit of I. Okay, let me write this definition. So such a limit of I such that when the angle of refraction, or you can say if you take I to be the value of C, a particular angle it will reach if you are increasing I angle of incidence in this optically denser medium. So when due to this angle of refraction reaches 90 degree, then we'll say such angle I is equals to C, which is basically critical angle. So critical angle is that angle of incidence in the optically denser medium such that at such angle, when the ray is incident in optically denser medium towards optically rarer medium, the angle of refraction becomes 90 degree. Got it? Critical angle. Now what's the next thing? Okay, so that's understood, but where it's like, the topic is in total internal reflection. So where the reflection is occurring? The topic is total internal reflection. Where the reflection is occurring? See, if you see, this is the beauty of this topic. Now, if you just increase the angle I a little bit greater than the critical angle, then you will not see such a refraction, but what you will see is reflection. That is following the laws of reflection. Okay, that is this theta will be equal to this theta for all the rays. Okay, so you can assume, suppose from a source of light, infinite number of rays are going from this optically denser medium to optically rarer medium. Okay, so what's going to happen? Suppose many rays will be grazing the surface, some will be just getting refracted. But at a certain angle where I is greater than even the critical angle, all the rays will go inside again. So following the laws of reflection. So this process is known as total internal reflection. Got it? This process is known as total internal reflection. That's fine, students. I hope you understood this thing. I'll give you the slides. Yeah, see, this is a picture in front of you. Suppose it's an aquarium or something like this. Flowers are, suppose flowers are trapped in some glassy kind of showcase, okay, and water is present. Aquarium, you can say more probably, more like if you want to understand this topic. So what happens, sometimes the light gets reflected inside and inside and inside and inside, due to which you see a lot of flashes, a lot of flashlight you see, but you're not able to see the proper thing inside. So that's due to total internal reflection. Got it? So every medium, every pair of mediums, say, because we need two mediums to observe this thing, no? And other medium may, is it? Yes. So we need two mediums, no, having two refractive indexes. So every medium is having its own critical angle. You can't say water or like water ka, suppose water and air pair or glass or air pair. Inka, you can't say like this, inka critical angle fixed over. No, it is never different. Of course, it is different. Air ka one hai, it is 1.33, it is 1.5, it is 1 again. So if refractive indexes are different, critical angle also will be different. No, got it? Okay, let us find one critical angle, then we'll end it. If suppose someone asks from you, students, someone asks from you this thing, that is supposed to find what? Suppose someone asks from you to find, say, to find critical angle. No, the spelling is this, critical angle when ray goes from water to vacuum or air. So what will be your answer? Simple. Suppose this is a boundary separating two mediums. This is suppose water. Okay. And suppose if rays goes like this is perpendicular. So we want this angle to be critical angle, na? Okay. And this is water. Water is having n equals to 1.33. So this must be critical for this angle of refraction must be 90 degree. Okay. So just apply the laws. इसी medium में इसी angle का sine. So how to apply? N which is equals to 1.33 multiply this thing with sine of the rays angle here. So that is C here. And next is what? You know, this refraction angle here is already 90 degree because this is the phenomenon of, the theory which we studied for total internal reflection and also the critical angle, the part of that, the basic foundation of that. And that we know this thing, it will be 90 degrees. Then only the angle of incidence will be critical angle. Critical angle, refracted angle is what? 90 degree, angle of refraction with the normal. So the medium is what? Air or vacuum. Air or vacuum ke liye n is 1. So 1 into sine of 90 degree. So this you will get as equals to 1.33 multiplied by sine C. You know, sine 90 degree is what? 1 here. So we'll get critical angle as 100 upon 133. If you solve it, it will be somewhat like this, sine inverse 100 by 133. Just solve and you'll get the answer. This is the critical angle for the pair of water and air medium. Okay. Similarly, you can find it out for say water, okay, and glass. Suppose this is glass. Okay. So, but the thing must be like this. Don't get confused. Okay. This is water. But the ray must goes from denser medium to rarer only. So the glass is more denser. Then only it will graze. No, refraction will occur then only. No. And we want 90 degree to be the angle. So always remember, critical angle process occurs how? It can't be from rarer to denser because it will be towards the normal then. Okay. So always from optically denser to optically rarer, then only the refracted ray will bend away from the normal, and we want the bending to be equals to what? 90 degree. Got it? If you do it opposite, rarer to denser, it will be what? Less angle. Got it? So students, this was all about today's class. Okay. And in the next class, we'll be seeing that if you keep your object and if you in a like a 3D kind of surface, so the locus of all those critical angle points, refracted angle 90 degrees. So for all those rays, for whose, okay, you understand like this, students, let me show you. Suppose I keep a source here, okay, and there will be number of million of rays will be going like this, okay. So when all of these rays passes from the denser medium to optically rarer medium, these will get reflected as what? Following the, suppose the incidence angle is critical for all these rays. So the angle of reflection will be 90 degree. So if you connect all those points on the top, you will get a circle. So I can say the locus of all the points at which angle of refraction is 90 degree for all the rays for which the angle of incidence is equals to the critical angle. We'll say locus of all such point is known as circle. You will see it as a circle when you will connect all those points, and it is known as circle of illuminance. Just for knowledge, this point is. Okay. Now, students, it's cleared. And in the next class, we will see what is apparent depth. That is what little bit, let me tell you, that actually the fish is at the depth of this, that is say capital H. But to your eyes, when you are standing in the top of the hill or some pond is there nearby you, if you observe the fish, it will appear to you at this much depth. Suppose this is H depth. Okay, let me, because it's a depth, so let me denote it with capital D, and this is small d. Okay, so isn't it a beautiful phenomenon of the optics? Yes. So we'll study in the next class this. Why, to my eyes, I mean, a fake thing is appearing. It's a virtual thing. It's so much illusion. Okay. But actually it is at this much depth, greater than what is appearing to my eyes. So we'll understand this. And also the concept used in this is this refraction only. Got it? Now, students, I'm ending this class. So that was all about today's class. Bye bye, everyone. Take care. Bye bye, everyone. Take care. Okay. Yes. Bye bye, students. So we'll meet in the next class. Okay. With more concepts for apparent shift and normal, apparent depth and normal shift and all those things. Shift via the glass slab and refraction to via spherical surfaces. Okay. Then at last, prism and optical instrument, a little bit, not a lot. Okay. Bye bye, all the YouTube students. I'm ending the class. Goodbye. Okay. Take care. We'll meet in the next